Augmented reality, AR, is a technology that allows users to see and interact with virtual objects and information in the real world. It involves superimposing computer-generated images, sounds, and other sensory inputs onto the physical world in real time, creating a hybrid reality that blends the virtual and the real. There are several ways in which AR can be implemented, but the most common method involves the use of specialized devices such as smartphones, tablets, or AR glasses. These devices are equipped with sensors and processors that are able to capture and interpret the user's surroundings, as well as display virtual content on top of the real world. The key components of an AR system include a display. This can be a screen on a smartphone or tablet, or a transparent display on AR glasses. The display is used to show the user the augmented reality content. Sensors. These include cameras, gyroscopes, and other sensors that are used to capture information about the user's surroundings. The sensors allow the AR system to understand the user's environment and position, as well as detect and track objects in the real world. Processor. The processor is the brain of the AR system, responsible for processing the data from the sensors and determining how to display the augmented reality content. Software. The AR software is the program that controls the AR system, including the user interface, the virtual objects and information that are displayed, and the interactions that are possible. To use AR, the user first needs to install an AR app on their device. When the app is opened, it uses the device's sensors and processor to capture and analyze the user's surroundings. The app then uses this information to determine the appropriate augmented reality content to display, based on the user's location, orientation, and other factors. For example, if the user is using an AR app to explore a city, the app might display virtual landmarks and points of interest on top of the real world, as seen through the device's camera. The user can then interact with these virtual objects, for example by tapping on them to learn more about them or by using gestures to navigate through the virtual content. AR has numerous potential applications, ranging from entertainment and education to commerce and industry. Some examples include gaming. AR games can allow players to see and interact with virtual objects in the real world, for example by using their smartphone to shoot virtual aliens that appear to be hiding behind real-world objects. Tourism. AR apps can provide tourists with information about landmarks and points of interest as they explore a city, or help them find their way with augmented reality maps. Retail. AR apps can allow customers to try on virtual clothing and accessories, or see how furniture would look in their home before they buy it. Training. AR can be used to provide immersive, interactive training experiences, for example by simulating complex equipment or processes in a safe and controlled environment. Overall, augmented reality has the potential to enhance and enrich the way we experience and interact with the world around us. As the technology continues to evolve, we can expect to see even more exciting and innovative uses for AR in the future. AR glasses are specialized devices that are worn like eyeglasses and are designed to display augmented reality content. They work by superimposing computer-generated images, sounds, and other sensory inputs onto the user's field of view, creating a hybrid reality that blends the virtual and the real. To use AR glasses, the user needs to install an AR app on their device, which can be a smartphone or a dedicated computer that is connected to the glasses. When the app is opened, it uses the device's sensors and processor to capture and analyze the user's surroundings. The app then uses this information to determine the appropriate augmented reality content to display, based on the user's location, orientation, and other factors. AR glasses can be controlled using a variety of methods, such as voice commands, gestures, and touch. For example, the user might say "show me the nearest coffee shop" to bring up a list of nearby coffee shops, or use a hand gesture to navigate through the virtual content. Retina projection is a technology used in some augmented reality (AR) devices to display virtual content directly onto the user's retina, creating a more immersive and natural AR experience. There are several ways in which retina projection can be implemented, but the most common method involves using lasers or other light sources to project the virtual content onto the user's retina. To use retina projection, the AR device first needs to capture information about the user's environment and the position of the user's eyes. This is typically done using a combination of cameras, sensors, and processors. Once the AR device has this information, it can use algorithms to calculate the appropriate light patterns to project onto the user's retina. These light patterns are then sent to the display system, which uses lasers or other light sources to project the virtual content onto the user's retina. The user perceives the virtual content as if it is part of the real world, because the light is being projected directly onto their retina. This can create a more seamless and immersive AR experience, as the virtual content is not separated from the real world by a display or camera. There are several challenges to implementing retina projection in AR devices. One challenge is creating a display system that is small, lightweight, and energy efficient enough to be portable. Another challenge is developing the software and algorithms needed to accurately project the virtual content onto the user's retina, taking into account factors such as the user's eye movements and the curvature of the retina. Despite these challenges, retina projection has the potential to revolutionize the way we experience augmented reality. It could allow for more natural and seamless AR experiences, as well as enable new applications that are not possible with traditional AR displays. Overall, retina projection is an exciting and promising technology that has the potential to greatly enhance the way we see and interact with the world around us. As the technology continues to evolve and improve, we can expect to see even more exciting and innovative uses for retina projection in the future.